Hello everyone and welcome back. So this time we're going to do a second example working with free body diagrams and our equations of equilibrium. So as you can see here, we have a little bit different situation. We have a mass here, we have a mass here, and we have a bunch of ropes holding them all together. What I want us to find out is the tension in the cables DE, EA, and EB. So this cable right here, here, and here. Unlike previously, we don't know the weight of this weight A. We don't know what it is. Now, you could do this in one step, but I suggest you do it in two and draw two free body diagrams, one for here and then one for here after you solve the first. Okay, so how are you going to do it? Well, you can draw a free body diagram for point E and then use your equations of equilibrium. It's not going to be all that difficult, but it's not always super easy either. So I'm going to give you a moment. I'm going to count to 3, and then I want you to go and do it on your own. Okay, so 1, 2, 3. Okay, hopefully you've paused. Hopefully you've gone and done it on your own. If you haven't, pause now, and then come back later. So let's jump on and see how we solve this problem. So first off, a free body diagram. Now we drew it right here for point E. And the one thing you had to realize for point B is that this is a cable, or is a pulley, and it's a frictionless pulley because it didn't tell us it had any friction. And so therefore, the tension on one side would be equal to the tension on the other side. So this tension EB is something we actually already know. It's going to be 40 kilograms times 9.81, and that's going to be newtons at the end. It's 9.81 meters per second square. That's gravity for the SI system. Then we apply our equations of equilibrium. Just like last time, we're going to break everything into components. So you see that they've already done that right here. They did cosine of 30 and sine of 30. The other two, luckily, are directed along the negative y-axis and negative x-axis, so we don't actually have to do anything with them. But let's go ahead and break up this force, or this tension EB, into its components and see how we do that. So first we draw our little force triangle. I'm just going to call it TBX and TB, oh my, I can't believe that, TBY and TBX right here. And this is 30 degrees. So with that in mind, we calculate these things right here. And what we find out is that, well, TBX is on the adjacent side, so that would be equal to the tension B times cosine of 30, and TBY is on the opposite side, so it would be TB sine of 30. So this would be for the X, this would be for the Y. And you see that has been placed right here. In the X equation, we have cosine of 30, and the Y equation, we have sine of 30. That leaves us only two unknowns. We have two equations, and therefore we're able to solve. Okay. So that's it. So these problems, they aren't that difficult. As long as you write down your equations correctly, you can probably solve them without too much difficulty. But just be very careful. Make sure that you don't forget to write your arrows in the correct direction. Most of the time they'll give you just a negative sign. Sometimes they'll throw off your answer entirely. Also be careful that you remember, well, like right here, we had to remember that these two cables have the same tension because they're going over a frictionless pulley. Other things to remember. You don't necessarily need to know the weight here. We didn't have to know that to solve this problem, so don't get freaked out if it has things that you aren't quite sure how to solve. And remember this, if you have three unknowns and you only have two equations, you need to find out something from the information here. If we had just looked at point E and not considered this at all, hadn't considered this weight at all, then we couldn't have solved. We had to use this weight to solve for one of our unknowns. So that is where our third equation came from. Okay, so this is our second example. I hope it helps you, and I will see all of you next time. Bye-bye.